Today we're going to look at the unit circle. By definition, the unit circle is a circle with center 0, radius 1. The unit circle offers us insight into the special triangles of 30 degrees, 45 degrees, and 60 degrees, along with all of the related triangles. Let us begin by looking at the definition of the trigonometric ratios of sine theta, cosine theta, and tangent theta. As we've seen in the previous lesson, sine theta is equal to the y-coordinate divided by the radius vector r. The cosine ratio is equal to the x-coordinate along our terminal arm divided by my radius vector r. Tangent theta is equal to our y-coordinate divided by our x-coordinate. Now, the unit circle is really helpful simply because the radius r is equal to 1. And if we substitute r is equal to 1 into our formulas for sine, cosine, and tangent, we get left with something much simpler, that sine theta is equal to the y-coordinate. Cosine theta is equal to the x-coordinate. Tangent theta is still equal to y divided by x, which is the slope. Let's take a close look at 4 very important points. To the right of the origin, we'd have this point. This is where our angle in standard position will be 0, or 360. The coordinates of this point is 1, 0. At the top of the circle, this is 90-degree rotation in standard position. The coordinates are 0, 1. To the left of the origin is 180 degrees. Our coordinates are negative 1, 0. And at the bottom of the circle is 270 degrees. Coordinates of that point are 0, negative 1. So at the moment, we have 4 points. And these 4 points do provide insight into the sine, cosine, and possibly the tangent ratio of these 4 positions. So for example, you may want to take out a calculator to verify this, but the cosine of 0 degrees is 1. In other words, locate where 0 degrees is on the unit circle. Ask yourself, what is the x-coordinate? The x-coordinate is 1. So the cosine of 0 degrees is 1. Cosine of 360 degrees is also 1. Same position, same coordinate. The sine of 0 and 360 degrees is 0 because the y-coordinate is 0. The same argument can be made for 90 degrees. The cosine of 90 degrees is 0. The sine of 90 degrees is 1. 180 has a cosine ratio of negative 1. The sine of 180 degrees is 0. At the bottom of the circle, 270, the cosine of 270 is 0. The sine of 270 is negative 1. Allow me to pick up this triangle and put it in my circle. I'm going to get rid of all of the extra information just simply by zooming in. So I'm going to take that circle, take that triangle, the first triangle that we constructed, the 30-degree triangle, and I'm going to plop it in our unit circle right in the first quadrant. Now, what we can see is here, this will determine my xy coordinates, this point on the terminal arm. If we take a look at the red triangle, we can see that the long side, which will determine our x-coordinate, is √3 over 2. The height of the triangle here will be 1/2. So I'm just going to a little text there. For 30 degrees, we can see that the cosine of 30 degrees is root 3 over 2. The sine of 30 degrees is 1/2. Moving on to the quadrant 2 related angle to 30 degrees. Now this angle will be 30 degrees less than 180, so that would make that angle 150. This angle, 150, has a cosine ratio of negative root 3 over 2 and a sine ratio of 1/2. The quadrant 3 related angle to 30 degrees is 30 degrees more than 180, which is my 210 degrees. 210 degrees has a cosine ratio, so the cosine of 210 degrees is negative root 3 over 2. The sine of 210 degrees is negative 1/2. Last but not least, in the related angle family, here we have it, related to 30 degrees in quadrant number 4, will be 330 degrees. This is the unit circle. We're not done quite yet. However, it should become apparent that there is deeper organization in the sine, cosine, and tangent ratios.